Okay, so we discussed critical points, we discussed local min and max, global min and max, extreme values, all that good stuff. Now everything's going to come together in the first derivative test. And this really is the algebraic method to determine whether an extreme value is min or max, whether it's local or minimum, or local or global, that sort of thing. So again, if we have a function, or for a function, if we have a critical point, okay, then we say we're going to have a local minimum. This critical point is going to be a local minimum if, now I'm going to make a little chart here, if, okay, and I'm going to put x is equal to c on it, if f of x is decreasing to the left of it, okay, so it looks something like this, and to the right of it, it's increasing. Okay, so when we make a sign chart, or I'm going to actually call it an increasing and decreasing chart, decreasing chart for the function, at a critical point, we should see this behavior occurring. Similarly, we're going to have a local maximum if, and I'm going to draw the same chart, if at x is equal to c, we have it increasing to the left and decreasing to the right. Okay, so again, this would be an increasing, decreasing chart for f of x. Okay, and now if neither of those occurs, we get what we call a saddle point. So this would be, there's a couple different cases. So if you have, again, at x is equal to c, you could either have decreasing, decreasing, or you could have at x is equal to c, you could have it increasing and increasing. Okay, either one, it just does not switch. Okay, so 3 different cases, and the process, to do this, is outlined here. This I copied directly from the notes, so feel free to refer to this, and I actually strongly encourage you to get this out and have this opened up while we go through the next example, because I'm going to kind of walk through this flow chart as we do the next example. Okay, so directions here are to find and classify all extrema of f of x as f of x is defined below. Okay, so we have this function. Okay, step 1, or really the first stage in the flowchart, we need to determine f prime of x. Okay, so this is equal to, and we'll just use the power rule, this is going to be x to the 4th plus, and then bring that down, and I get 2x, after I simplify, 2x to the 3rd minus 3x squared. Okay, and the 3 goes away under differentiation. Now I can factor this, and typically you will have to factor this. I'm going to pull an x squared out, and I'm left with x squared plus 2x minus 3. Okay, and factoring that further, I get x squared, and then I have an x plus 3 and an x minus 1. Okay, and setting that equal to 0, that means, and now this is step 2, okay, and maybe I'll switch colors. Step 2, to find the critical points occur at x is equal to, and now let's see, set each one of these equal to 0 independently of each other. I get 0 here, negative 3, and positive 1. Okay. Now, great. So this is pretty much done. Next stage was to determine the domain. Okay, so domain. Well, what is the domain of a polynomial function? Well, domain is going to be minus infinity to infinity, so all real numbers. So it's the interval is open. And so this isn't too interesting, and actually I'm going to do a slight modification of the problem. I'm going to actually specify a domain. And I'm going to say this, we're doing the function over the interval -4 to 4. Okay, so really, let's change the domain, and the domain is just going to be -4 to 4. And so by getting a closed or being on a closed interval, the problem is a little bit more interesting and consequently a little bit more harder. Not too much harder though. Okay, so following the flowchart, our domain is now a closed interval, so we keep that in mind. What are the endpoints? Well, the endpoints here are just x is equal to 4 and also x is equal to -4. Okay, so keep those in the back of your mind because they will come into play in the next step and a little bit later too. Okay, so now we have to classify the extrema by making a sign chart. Okay, so we're going to make a sign chart for the derivative. Okay, so keep this in mind. We're going to make two kinds of charts. We're going to make a sign chart for the derivative, and then also with that, we're actually going to make a increasing decreasing chart for the function itself. But one step at a time here. So let's go ahead and we're going to put all of our numbers on a number line. So we have our endpoints, put those on our number line, just to know that we can't go beyond that. Okay, and then we have our critical points, so we have to put our critical points on here. So we have -3, 0, and 1. Okay, and they're not equal distance apart, that's fine. Okay, and so remember a sign chart, this is from pre-calculus. What we have to do is we have to take values in between and put them into the derivative. So I'm going to compute f prime of, say, 3.5. Negative 3.5 from this first interval. Second interval, I need to compute f prime of -1. Second one, I'm going to compute f prime of 0.5. Okay, and then this last interval, I'll just do f prime of 2 to make my life easy. And now remember, with a sign chart, you can compute the value, but really what you want to know if it's positive or negative. And I did this ahead of time. Feel free to verify this on your own. But when I did this computation, I got this to be a positive number, and these middle two to be negative numbers, and then this last one to be a positive number. So my sign chart looks like this. Plus in here, then I have a minus all in here, a minus in here, and a plus in here. Okay, and so following the flowchart, I need to, this is really enough to tell whether it's switching from increasing and decreasing, but what I'm going to actually do is go a step further and make a increasing decreasing chart for the original function. Okay, so pay attention to this as well. Okay, and so remember, if the first derivative is positive, that means it's increasing, so I'm going to go ahead and make my number line going from 4 to -4, and I'm going to put my other numbers on there, 0 and 1. And so when I do this, between -4 and -3 it was positive, so I am increasing, and then between -3 and 0 it was negative, so it's decreasing, decreasing, and then increasing. And so this allows me to really, now I'm in that kind of halfway down in the flowchart, and this really allows me to classify the extrema, or classify my critical points based on what they are. So here at -3, I actually have, it switches from increasing to decreasing, so this is going to be a local max. Okay, at 0, I'll come back to the endpoints in just a minute. At 0, it's decreasing and decreasing. This is actually a saddle point. Okay, it does not switch, but yet the first derivative is equal to 0 there. Now at positive 1, it goes from decreasing to increasing. This is a local min. Okay, and now we also have to be sure to classify the endpoints as well, because we're on a closed interval. Okay, and so looking at this, if I increase, all the way up into -4. That's saying like it's going something like this, and then at 4 it stops. This is actually going to result in this being a local max. Okay, and then similarly down here, if you start at 4 and it's increasing from 4, that means that this is a local min. Okay, so I've classified the local extrema, but remember that since we're on a closed interval, okay, and following the flowchart, the domain is a closed interval, we have to classify the global extrema by making a list of function values. So what I'm going to do is I'm going to make an x and a f of x table. On here goes all my critical points and endpoints. So 0, 1, 4, and put these into the function. Okay, and when I do this, I went ahead and did this before. The function values I obtained were -9.8, 21.9, 3, 2.7, and 271.8. Okay, so now I need to classify these as global max, or classify one of these points as a global max or global min value. Now, global max is the most positive value, and that actually occurs here. So this is going to be where my global max occurs. So I say global max at x is equal to x is. Let me erase that. Global max at x is equal to 4. And then now for the global min, I look for the most negative value, and that occurs here. So I say there's a global min at x is equal to -4. Now, in this case, it happened to work out that the endpoints were your global min and max values. Not always the case. So please keep that in mind and don't automatically assume that the endpoints are the global min or max value. And that is a very long example of how to classify local and global min and max values using the flowchart with the example here.